Welcome to the Video Professor's series of computer learning tapes, the nation's #1 computer trainer. We'll take you step by step through learning to use your computer software. On the screen now are some other tapes available in our series. When using these tapes, we suggest you watch them in their entirety, then go back with your computer and practice each step. In keeping with the Video Professor's dedication to giving you the best lesson possible, we have packed these tapes with information and sometimes move at a pace that is faster than you will be able to follow along with as you are working with your computer. Remember, you can always pause or rewind the tape to learn each part. Now let's get started. Welcome to my lesson on learning Windows 95, the most popular operating system for personal computers in use today. In this lesson, you'll learn what a computer system is comprised of and how it processes information. You'll discover the types of hardware that make up a computer system and what functions they serve. In addition, this lesson explains the basic features of the Windows working environment. I'll teach you how to identify and use the Windows 95 desktop tools. You'll discover how the operating system works with hardware and software alike. And we'll look at file management using the Windows Explorer. Before going any further, I'd like to introduce to you my student helper, Suzanne. Just follow along with her and you will soon understand how to use your computer and Windows 95. Suzanne, many people think of a computer as a piece of machinery. The computer machine or hardware is only one part of the computing system. A computing system actually is comprised of three elements: the hardware, which you can see and touch, the software or programs which make the hardware do the work you want, and you, the user, the most important part of the system. We'll start with an explanation of the hardware, the computing machine. Suzanne, to help us understand hardware a little better, let's break down a typical computer advertisement. Here's one from Mammoth Computers. This particular system has a TX150 motherboard with a 200 megahertz Pentium processor, 512K pipeline burst cache, a 3.1 gig hard drive, and...
Oh, Professor, what is all this lingo?
The jargon does get a bit intimidating, but don't worry. In this section, I'll explain how they relate to a computer system and what they should mean to you. Suzanne, let's begin our journey into computer hardware by looking at input and output hardware. You see and touch the input-output devices, or I/O devices, every time you use a computer. Let's start with the keyboard, since it is the main component for entering data and instructions into the system. Our ad shows a 104-key Win95 enhanced keyboard. This is simply a description of the number of keys. With 104 keys, this keyboard includes a full set of 12 function keys, a separate numeric keypad, and specialized movement keys, such as the arrows. Most keyboards have the same kinds of keys, but vary as to where these keys are located. The Win95 Enhanced tells us that some of the special function keys on this keyboard are customized for the Windows 95 operating system. Suzanne, our ad also shows a 2-button mouse. This input device allows you to give commands and select options. On the computer screen, a pointer represents the movements of your mouse. It may appear as an arrow, I-bar, or other symbol. The pointer moves in tandem with the mouse. In place of a mouse, some computers have a trackball or a touchpad that moves the pointer. Each of these performs the same functions as a mouse. Another input device that is becoming very common is the scanner, an optical reading device which can detect images and store them on your hard drive. In addition to scanners, digital cameras also let you input images into the computer. Other input devices include microphones and MIDI players. At the other end of the process are output devices, which are used by the computer to give information back to the user. Monitors, speakers, and printers are the most common output devices, so let's take a look at them. The monitor is the screen where you can see your work. Monitors vary widely as to the resolution, meaning the sharpness of the image. Resolution is described in pixels or in dot pitch. Pixels are little dots of light that make up the screen image. The pixels are measured across and down. Dot pitch is a measure of the space between the pixels, and a lower dot pitch means a sharper image. Most monitors are color, although some laptops use monochrome screens to conserve power. Laptop computers typically use either LED or plasma displays because they take less space and power. Monochrome monitors display information in one color, usually over a blank screen. Speakers are another output device that can be added to a computer system. They produce sounds that are on music CDs and those accompanying software packages. Printers are also output devices, and they vary as widely as monitors. The three most common types are dot matrix printers, laser printers, and inkjet printers. Dot matrix printers use little dots to create letters and graphics. They vary as to resolution and make letters look a little ragged. Inkjet printers, sometimes referred to as bubble jets, also use little dots to create images. However, they group the dots much closer together than dot matrix printers, so their images look much better. They are relatively inexpensive and produce black and white or color images worthy of most business applications. Laser printers create images using a process similar to copiers. They fuse ink to the paper in a heat process. Laser printers are generally faster and more expensive than inkjet printers, but they do produce better looking text and graphics. There are more choices available in I/O hardware, but you get the idea. Input devices allow you to put data or commands into the computer, and output devices are how the computer gives information back to you.
So, Professor, when this stuff goes into the computer, what happens to it?
Good question, Suzanne. We need to look at the processing and storage functions as well as the hardware that's used for these purposes. As I mentioned earlier, the I/O devices are usually the easiest to understand because you can see them. But the brains of the computer are inside the box where you normally can't see them. Suzanne, let's take a quick tour of this environment and then break down each of its components. A computer is built around a piece of hardware called a motherboard, which is simply a board with some electronic pathways and slots to hold other parts. Three important components reside directly on the motherboard: the CPU chip, pipeline burst cache, and the memory chips. The slots on a motherboard are places where controller cards are plugged into. Other hardware typically found inside the box includes a hard drive, a floppy disk drive, a CD-ROM drive, an internal modem, and a power supply. As you can see by this simplified illustration, it can get pretty crowded in the box. Of course, it's important that they are able to work together without any conflicts. Now let's start with the part of the computer that actually computes, the central processing unit. In our ad, the system's central processing unit, or CPU, is listed as a 200 megahertz Pentium chip. Basically, it takes the data and instructions that you input and turns them into output. For example, when you press the letter A on the keyboard, the signal moves through the keyboard cable to the motherboard, where it is stored briefly in memory and pipeline burst cache until the CPU reads it. Then it sends a different signal to the monitor to display that letter on the screen.
Professor, what does our ad mean by saying the CPU is 200 megahertz?
Megahertz is simply a way of measuring electronic speed. The higher the number, the faster your computer should perform different tasks. Signals from your keyboard, or any input device for that matter, are first stored in memory before the CPU processes them. Computer memory is handled by RAM chips, which are located in the motherboard, usually right next to the CPU. RAM stands for Random Access Memory. Our computer ad lists the system as having 32 megabytes of EDO RAM. We know what RAM means, so let's see what they mean by 32 megabytes of EDO RAM. A byte is the measuring unit for information, and it's about the same as one character, like an A or the number 1. A megabyte is 1 million bytes, about 1 million characters of data. Essentially, the advertised system's temporary memory should be able to store close to 32 million bytes of information, which can come in handy since many software packages require 12 or more megabytes of RAM in order to run. Suzanne, we have another form of memory available to us. It is called pipeline burst cache. It is located directly on the motherboard next to the processor. It acts as a conduit between RAM and the CPU. This boosts your computer's performance by allowing the processor quicker access to data on the memory chips. As I mentioned earlier, the motherboard has slots where controller cards are plugged into. Controller cards allow I/O devices to communicate with the motherboard. Basically, they carry the signals between the CPU and those attachments. A system may have a controller card for sound, another for a monitor, and yet another for a scanner. Hard drives, floppy drives, CD-ROM drives, and modems can be attached directly to the motherboard without a dedicated controller card. Suzanne, there is one essential fact that you should remember about memory. It is temporary. If the power is shut off to your system, whatever is left in memory is lost. Floppy and hard disks are the most common permanent storage devices. The term floppy disk refers to a computer software disk that you insert into your system's disk drive. They are called floppy because the magnetic media within them is bendable. The standard disk size is the 3.5-inch disk. Double-density floppy disks hold 720 kilobytes of data, while high-density floppy disks hold 1.44 megabytes of data. When a floppy disk is inserted into the disk drive, the computer reads the information stored on it and loads it into the computer's memory. From there, it can be copied to another storage device, such as the hard drive. The hard disk has much more storage capacity than floppies. They store data on rigid disk, thus the name. The advertised system lists a 3.1 gigabyte hard drive as part of its features. A gigabyte is 1,000 megabytes, so this hard drive can hold essentially 3,100 megs of data. Most application programs come on floppy disk or on CD-ROM disks. When programs are installed on your computer, they are essentially copied from floppy disk or CD-ROM onto the hard disk. Once on the hard drive, you can access the program over and over. Hard drives are not indestructible. They can sometimes crash and lose the data stored on them. A utility program can help recover data, but the best way to protect yourself is to have a backup system. This is why many computers are equipped with a backup tape drive. They allow you to copy the contents of your hard drive, which is a good way to preserve files and programs. Suzanne, our ad lists another type of drive, a CD-ROM drive. It reads data from CD-ROM disks. ROM stands for read-only memory, which means the drive can only read information from the CD. It cannot store or write additional information to the CD.
Professor, can a computer CD drive play my music CDs?
This drive is just like a compact CD player that plays music, and the CD disc that goes into that drive not only holds music, it can hold sound effects, dialogue, text, program code, video, and items related to multimedia presentations. CD-ROM discs are very useful because they can hold entire programs that would normally take up storage space on the hard drive. For example, a single CD can hold all of the information contained in an encyclopedia, including pictures and search programs. If you are running an application directly off a CD-ROM disk, the necessary information is stored in memory. However, if you create any files associated with that application, they are saved either to the hard drive or a floppy disk. So far, we have talked about how the different pieces of hardware communicate with each other. Now, let's look at using the computer to communicate with the outside world. Most new computers come with a modem or a fax modem. Ours is no exception. It has a 33.6 voice fax modem. A modem is a translator and a necessary piece of hardware if you wish to access the internet or email someone. The word modem is a combination of its two functions, modulate and demodulate. A typical modem will send and receive 28,800 bytes of information a second. At this rate, it only takes a second or two to send a typical 3-page business letter. Most modems sold today, including the one in our advertisement, include fax capabilities so you can communicate either with another computer or with a fax machine. You'll also notice that our ad lists the modem as a voice fax modem. This modem also allows you to use your computer to make and receive phone calls. Suzanne, that's a fairly quick overview of hardware options. Now, let's turn our attention to the stuff that makes everything run, the software. Two types of software that we are especially interested in are operating systems and application programs. An operating system like Windows 95 or DOS is vital to your computer system's operation because it works behind the scene performing vital functions that make your computer perform. The operating program is usually stored on the hard drive and then is loaded into memory automatically whenever the computer is turned on. Once it's loaded, the computer is ready for your instructions, which for most of us revolves around an application program. Earlier, we saw how data travels through the hardware components. To facilitate this, an operating system translates the instructions you give the computer into binary codes that the hardware understands. It acts a little like a traffic light. It keeps track of all the data and program information being routed from one piece of hardware to another. It makes sure your commands reach the correct piece of hardware at the right time without running into each other. An operating system is responsible for displaying your work on the monitor as well as sending data to the printer. Without the operating system's help, your hardware can't perform the desired results. Another part of an operating system's job includes managing files, allowing a user to open files that have been stored on the hard drive or floppy disks, and also to save new work onto a disk for future use. Application programs such as Lotus or Microsoft Word are easier to understand because they are the types of software that help you do personal or business tasks, like word processing, database operations, checkbook balancing, and accessing the internet. To be able to use an operating system or application program in most cases, it must be installed on your system. This simply means transferring the software that comes on floppy disk or CD-ROMs to the hard drive. Some software, like the Windows 95 operating system, comes pre-installed or preloaded on your computer's hard drive, which comes in very handy since an operating system must be present on your computer before you can install and access an application program. Now that we understand how all the components of a computer work, let's delve into the operating system that is installed on more personal computers than any other operating system in use today. At this point, I want everyone